Hello everyone, welcome to Edupedia World Videos. In today's lecture, we will discuss about refining of impure metals. The metals extracted by the reduction operations contain some impurities such as carbon, silicon, phosphorus, other metals, dissolved oxides, sulfides, etc. So, the impure metals require refining. The process of purifying impure metals is called refining of metals. The refining method to be used depends upon the nature of metal to be purified as well as the nature of impurities to be removed. Some methods are designed to recover the precious metal impurities such as gold, silver and platinum. The methods which are commonly used for refining of metals are distillation, liquation, oxidation, electro refining, vapor phase refining, Arkel method and zone refining. The first method which we are going to discuss is distillation. Distillation is used for the purification of low boiling volatile metals such as zinc, cadmium and mercury. The impure metal is distilled in an iron retort. The pure metal distills over, leaving behind the non-volatile impurities in the retort and is condensed in a receiver. This method is used for low boiling volatile metals. Now, the second method which we are going to discuss is liquation. This method is used when the melting point of the metal to be purified is lower than those of the impurities, and the impurities are not miscible with the metal. This method is applicable to easily fusible metals such as tin, lead and bismuth. We can see this figure. The impure metal is heated at the top of a sloping hearth and the temperature is maintained slightly above the melting point of the metal to be purified. Flows down the inclined hearth and collects in a receiver at the bottom of the slope. As we can see that pure metal is collecting over the receiver. The infusible solid impurities remain behind on the hearth. So, this is liquation method. Now, next method of purification is oxidation. This method is used when the impurities present in the metal have greater affinity for oxygen and undergo oxidation more readily than the metal itself. Molten cast iron or copper is purified by this method. This is Bessemer Converter. The impure metal is melted in a Bessemer Converter and a hot blast of air is passed through the molten metal. When the impurities are oxidized to their volatile oxides such as CO2, SO2, P4, O10, etc. and get removed. This is oxidation process and we use Bessemer Converter for this process. Now, next method is electro refining. This method is used in the refining of copper, silver, gold, zinc, tin, lead and aluminium. The plates of impure metal are made anode and a plate of pure form of the same metal is made cathode in an electrolytic cell. The electrolyte used is an aqueous solution of salt. Impure metal is the salt oxidized to cation at the anode, which passes into the solution. The electrolyte consists of an aqueous solution of salt of the metal. So when an electric current is passed, the anode undergoes dissolution while the pure metal is deposited on the cathode. The insoluble impurities settle at the bottom of the electrolytic cell and are recovered as valuable anode mud. The soluble impurities remain in the solution. Highly pure metal is produced by this method. For example, in the electro refining of copper, anode is made of a block of impure copper containing traces of iron, silver and gold. Cathode is made of a thin plate of pure copper, and the electrolyte is a solution of copper sulfate containing small amount of dilute H2SO4. When electric current is passed, the reaction occurs at cathode it will be like this: Cu2 plus 2 electrons, copper will be formed, while at anode it will give Cu2 plus 2 electrons. Copper dissolves from the anode and goes into the electrolyte, and an equivalent amount of copper from the electrolyte gets deposited on the cathode. Next method is vapor phase refining. In this method, the impure metal is reacted with a suitable reagent so that the metal is converted into a volatile compound while the impurities are left behind. The volatile compound is decomposed to pure metal by heating. This method also produces highly pure metal. Next method is Van Arkel method. This is an important refining method to obtain metals of very high purity. This method is used for purifying tin, zirconium and thorium. The method is based on the thermal decomposition of an unstable compound of the metal. The metals are heated with iodine in an evacuated vessel when volatile iodides are formed, and the impurities are left behind. The gaseous iodides are decomposed by heating over a white hot tungsten filament. The pure metal is deposited on the tungsten filament. This is Van Arkel method, and it's used to obtain metals of very, very high purity. Now, our next method is zone refining. It is an important refining method to obtain pure metal. This method is based on the principle that when a molten impure metal is cooled, the pure metal crystallizes out while the impurities remain in the melt. That's why this method is also called selective fusion recrystallization process. A rod made of the impure metal is placed inside a long quartz tube and a circular heater is fitted around the rod. The rod is heated at one end while the heater and a narrow zone of the metal melts. The heater is slowly moved towards the right when the pure metal recrystallizes out of the metal, while the impurities pass into the adjacent molten zone to the right. So, the left part of the rod contains pure metal, while the right end of the rod containing the impurities is chopped off and removed. Very pure silicon and germanium of semiconductor grade is obtained by use of this method, and it is used in the electronic industries. Thank you for watching Edupedia World videos.